Welcome to day one of your software engineering internship. I am absolutely thrilled to have you here. We're diving straight into the taxonomy of software testing today. Now, I know testing might not sound quite as glamorous as shipping a flashy new feature, but honestly, understanding this explainer is going to make you an absolute rockstar engineer. We're talking about the exact strategies that save companies millions of dollars, prevent massive public embarrassments, and, actually let you sleep at night after you push fresh code to production.
So, here's our game plan for today's explainer. We'll start with a quick welcome to bootcamp, then contrast manual versus automation testing. After that, we'll break down functional versus non-functional, run through smoke and sanity checks, and wrap up with the absolute power of regression testing. Let's just get right into it.
All right, Section 1, Manual versus Automation Testing. This is really our execution layer.
So, manual testing. It's exactly what it sounds like, right? It's you, an actual human being, physically tapping a phone screen, swiping through menus, or clicking around a website just like a real user would. Basically, you're actively trying to break things. You're making sure the software holds up under real-world, messy conditions. You might type weird characters into a password field, try to submit a form without an email address, or just aggressively click buttons way faster than normal. You're using your human empathy, and honestly, your common sense, to find those weird defects that a rigid, pre-programmed script would just completely breeze past.
And then we have automation testing. This is where you put your developer hat on and write a script to do all that tapping and clicking for you. So instead of manually filling out a login form every single time you tweak the app, you just write a specialized piece of code. That script spins up a browser, types the username, types the password, hits login, verifies it worked, and here's the kicker, it does it 1,000 times over in literal seconds. You can just let these automated tests run overnight while you're asleep, which gives you this constant, rolling baseline of stability for your core app.
Now, these two, they are not enemies. They're actually partners. Manual testing leans entirely on your human intuition to explore and find those unpredictable quirks that nobody would ever think to write a script for. But yeah, it's naturally slower. Automation, on the other hand, brings sheer speed, massive scale, and just relentless consistency. It's pretty terrible at guessing what a confused user might do, but it is absolutely brilliant at making sure your login button works the exact same way across 10,000 different test runs.
As a junior engineer stepping into this field, I really want you to burn this golden rule into your brain. Automate the repetitive, manually test the unpredictable. Your brain is way too valuable to waste clicking Add to Cart 50 times a day. Save your cognitive energy for the unpredictable, complex edge cases and let your automated scripts handle the boring daily chores. That's really how modern engineering teams move fast without completely breaking things.
Moving right along to Section 2, Functional versus Non-Functional Testing. Basically, what are we actually testing for here?
I like to think of this like building a house. Functional testing is asking, hey, does the front door open, close, and lock? It's totally binary. It either works or it doesn't. Non-functional testing, though, is asking, okay, but can that front door survive a Category 5 hurricane? So it's not just about what the software does, it's about how well it performs under intense pressure, different environments, and varying levels of stress.
Let's say you're building an e-commerce app. Functional testing means checking those hard, explicit requirements. Can the user actually add shoes to their cart? Can they change their mind and take them out? Can they enter their credit card and successfully complete the checkout? These are the fundamental basics. If any of these fail, the app is just fundamentally broken for the user.
On the flip side, non-functional testing asks the really tough questions. Like, sure, the cart works perfectly for one person, but is the server going to instantly melt down when 10,000 people try to buy those exact same shoes at the exact same second on Black Friday? Because we've all seen major sites crash and burn during a big sale. It also asks things like, is the credit card data actually encrypted and safe from vulnerabilities? Does opening the app drain a phone's battery in 5 minutes flat? This is all about the overall quality, reliability, and scale of the experience.
Okay, Section 3, Smoke and Sanity Checks. This is our rapid code diagnostics phase.
Imagine you just deployed a massive update to your servers. The very first thing you do is a smoke test. Fun fact, this term actually comes from old hardware testing, where you'd plug a machine in and literally see if smoke started pouring out of it. In software, you're basically asking, is the system literally on fire right now? You aren't checking every tiny little feature, you just want to know, does the app even turn on? Is the database connecting? Does the home screen load? It's a very shallow but very wide check for critical failures before you invest time into deeper testing. Now, once the smoke clears, meaning the system isn't completely dead on arrival,
you move on to a sanity test. Unlike the smoke test, which is broad and shallow, a sanity test is deep and incredibly narrow. You run this strictly on the specific new feature you just built. So if you spent the last 3 days coding a new Buy Now with one click button, your sanity test focuses entirely on proving that one specific button actually works in the live environment. You're essentially checking your own sanity to confirm your fix actually did what it was supposed to do.
So your immediate post-deployment flow looks exactly like this. Step 1, deploy the fresh code. Step 2, immediately run that smoke test to check for any fatal system-wide meltdowns. If it survives that, Step 3, zoom way in and run a sanity test just on your newly added feature. It's a really elegant process of elimination that ends up saving engineering teams massive amounts of debugging time.
Finally, Section 4, the power of regression testing. This is your ultimate safety net.
Regression testing is what ensures your brilliant, brand new code doesn't magically resurrect old bugs that you already squashed months ago. Look, in software engineering, code is deeply interconnected. Changing a single line in one file can easily ripple out and break something on the complete opposite side of the system. So, regression testing is simply the automated process of rerunning all your hundreds or even thousands of old tests every single time you change the code base. It verifies that all the old stuff still works perfectly alongside your new stuff.
For example, say you update the color and size of the shopping cart icon in the top corner. Seems totally harmless, right? But maybe because of some shared style file, that innocent little visual tweak somehow completely disables the user login page. It's basically the butterfly effect of coding. Having a robust suite of automated regression tests guarantees you catch that kind of weird, unintended side effect instantly, way before that broken login page ever reaches your actual users.
And that wraps up our bootcamp syllabus. As you finish day 1 of this explainer and let all these testing methodologies sink in, I want to leave you with a pretty provocative thought to ponder. We're currently watching artificial intelligence learn how to independently explore applications and write its own automated testing scripts. So, looking ahead, how will AI change the balance between manual and automated testing? Will we always need human intuition to sniff out those unpredictable quirks? Or are we heading toward a completely autonomous QA pipeline? Definitely something to keep in mind as you build your career. Thanks for hanging out with me for this explainer, and good luck out there in the code base.